So let's talk about growth models. So an economic growth model is set up to explain growth rates in real GDP per capita over the long run. And the fact that it's in the long run is important. The main factor that affects real growth rates is labor productivity. So labor productivity is the quantity of a good or service that can be produced by one worker or in 1 hour of work. So the question is, how can we become more productive? How can we increase labor productivity? So what we're saying is we want to make our workers either be able to produce more quantity in the same amount of time, or we want them to be able to be more effective per hour. That makes sense. So the quantity of capital per hour worked, that is a way to increase labor productivity. So quantity of capital can mean, for example, giving workers laptop computers, right? That is capital. That may make workers more productive. If I gave all of my students a laptop computer, perhaps everyone would be more productive. So to increase the quantity of capital per hour worked can make workers more productive. The second thing is to increase the level of technology. So a technological change, and that's what this triangle means, it's called a delta. So the technological change means a change in the quantity of output a firm can produce using a given quantity of inputs. So what we're saying here is if we use the same amount of inputs, can we become more effective and more efficient and increase our output? How can we do that? Well, with better machinery and better equipment. So, for example, robotics has a place here. A lot of assembly lines have become very mechanized because that increases the efficiency and the productivity of the labor line. So humans can be used on fine, detailed items, things that require the human eye and human judgment. But for repetitive tasks, we can let machines do that. So if we have better machines and better equipment, we can increase our output. That is increasing technology. The second thing is an increase in human capital. So human capital is the accumulated skills and knowledge that workers acquire from education, training, and or life experiences. So the more educated a worker is, the greater his or her human capital. So right now, the fact that you guys are all going to college, you're increasing your human capital. If I have some of my students perhaps are ex-military or current military, that is a different kind of training. That is also increasing your human capital. If you are bilingual or trilingual, then you have that increased human capital. So if I were to give each one of you a certain type of training, train you to, work on Excel or something like that, that's another type of human capital. So an increase in human capital will also increase our output. And then the last thing is a better means of organizing and managing production. So an example of this is the just-in-time system or supply chain management. So the just-in-time system is a system of inventory control that was invented by the Japanese. So Japan is a relatively small country. It is an island country. So they don't have a lot of space to put a lot of inventory, but they wanted to go into car manufacturing. So they developed this just-in-time, and basically what they did is instead of having a bunch of inventory in their warehouses, they would order things so that they would come in just in time to be used. And therefore, they did not have a lot of their money in inventory. So that is a better means of organizing and managing production. Supply chain management is another way. If you could reorganize, for example, like let's pretend we're talking about Amazon, the way that bags are packaged. If there was a redesign that would make it more efficient for workers to get the products into the packages, and every step was shaved off by 1 second, would that make a difference? And the answer is yes, because there's so many different steps and all those little seconds add up, and that means more money. So if you're more effective, if you're more efficient, then you can also command more profit. So now we're going to talk about the per worker production function. So the per worker production function measures the relationship between real GDP per hour worked and capital per hour worked, holding the level of tech constant, ceteris paribus, which remember means everything else is being held constant as well. So holding technology constant leads to diminishing returns. The law of diminishing returns shows us that as we increase more of one input, in this case capital, to a fixed amount of another input, in this case labor, output increases by smaller additional amounts, or output increases at a decreasing rate. So this is the graph, and then I'll explain it. So here, initially, as we increase capital, if we increase it here, then we get a big jump in real GDP per hour worked. And then we move it over here, and we get another big jump. But if we're up to this point here, if we move from here to here, that amount on this axis is going to be very small, meaning that we are still increasing, but at a decreasing rate. And for an example, let's use a donut shop. If you think of a donut shop, it is a set space, meaning it's only so big, and I am the manager. If I add one person, that's going to increase my output a lot, because now I'm not by myself. I've got someone that can, for example, do the cash register. And then I say, well, I'm going to add one more person, because that person can help me decorate the donuts and put them in the cases and put them in the boxes. And I'm going to see another big increase in output. But over time, maybe when I get to like the fourth or the fifth person, they're actually going to slow things down. The increase in output that I get from that fifth person might be very, very small, because they're just starting to get in the way of the rest of us. So maybe with 4 people, we can work out a routine where, I cut the donuts, somebody fries the donuts, somebody puts the sugar on the donuts, and somebody puts them in the case. But another person might just get in the way. So that would be a diminishing return on that investment in labor. So, what is the key to sustaining economic growth? Technology. Technological change is the key to sustaining economic growth. So technological growth increases output per hour worked, allowing the per worker production function to move outward to new frontiers. So when I say move outward, this is the function. It will move this way. It will move outward. So at every point, I will have more real GDP per hour worked. So tech can be combined with capital growth. For example, more efficient capital to replace older, less efficient capital is an example of technological change. So instead of adding, to my donut shop example, instead of just adding, maybe another cash register or another deep fryer, maybe I'm going to invest in something that is more efficient, that allows me to cut, 100 donuts at once instead of 1 dozen, and allows me to fry all of those donuts at one time. So that is an example of more efficient capital. So increased technology, more efficient capital, we can raise this production function to a new higher level. And in the long run, a country will experience an increased standard of living only if it experiences continuing technological change.